Hello, welcome to this lesson of our study of integral equations. And in this lesson we just learn how to convert a Volterra's integral equation to an ordinary an ordinary differential equation, okay, or an ODE. And then we'll just look at it. If you can solve it, then you continue solving it, okay? I hope you are cool with me. Alright, so if you have not subscribed to the channel, kindly subscribe to support the channel as well, okay? Okay, let's start. So given a Volterra's integral equation, I hope you understand why it is a Volterra, because for Volterra's integral equation, the upper limit is actually a function of x. Particularly in our course, the upper limit is supposed to be x, and here we have an upper limit to be x as well, okay? So if you have that, then to convert this to an ODE, okay, just read that with me. Differentiate, we have to differentiate with respect to x the whole of the VIE, that's the Volterra's integral equation, until the integral sign is no more. So what we are going to do is we'll pick an example that involves an integral sign like this, and then if you want to convert it to an ODE, you have to probably or definitely change the integral sign to a differential sign. In that, we'll have to differentiate the whole VIE to the point that we won't get any of the integral signs present again, okay? Alright, let's pick an example and go through it. So this is an example. Solve for the VIE below, and this is it, the integral from 0 to x, cos of the expression x minus t y of t equals, there's supposed to be a dt here, okay? Let me erase that and write it for you better. There's supposed to be a dt here, and it's equal to that, okay? So now with this, how do you go about it? How do you solve it? All that you have to do is that I said to solve something like this, you have to differentiate the whole of the question, okay? The whole of the integral equation, that is, in this case we have this as an integral equation, okay? Y of t dt equals s squared over 2. So we are differentiating everything in the equation, okay? So I'm taking my time to go through with the first question, and then probably with the second question I'll be doing some of the stuffs straight away, okay? So kindly pay attention to the first one, okay? I hope this is cool. So to differentiate this, we'll have to differentiate them term wise, okay? So first of all, you differentiate the left side of the equation, dx of this whole thing, okay? You have cos of x minus t y of t dt, and it's equal to d dx of our s squared. Or what do you have? You have s squared over 2, right? Now we know that the other side, when you differentiate the right side, is very simple. You get 2x over 2, and in fact this will take this out, and so you have x, okay? So with that aspect it's okay, but the other aspect is still with this one, okay? So if you remember, we've discussed how to do differentiation under the integral sign, okay? That is why you went to learn that one, okay? So we'll have to implement it here. So let's pick the left side alone, go through each differential, and then we'll get to know about it, okay? So with this, I'm picking only this part, okay, so that I will differentiate with this. The f of xt here, that we'll get from our ideas in differentiation and integral sign, this is equal to cos of x minus t y of t, because we said it's everything that is under the integral sign. So here our a is what? 0, and our b is equal to x, okay? So f of we said we'll have to get f of x comma b, and b is what? X. So f of x will give me cos of x minus x, because we said that wherever you see t, you put in x, okay? That is why this changed, okay? So the t aspect that will be affected, okay? And y of x, and this will definitely give me cos of 0. Cos of 0 is 1, so I'll have to get y of x, okay? Then we'll need the b dx, okay? So but let me first do f of xa, f of s comma a, and a is what, 0, so I have something like this, and this will be equal to cos x minus 0, and that will be cos x, okay? Then y of 0. We have y of t here, so I put t equals 0 there, okay? You know that the b dx is just differentiating b with respect to x, and b is what, equal to x. So when I differentiate l with respect to x, I'll get 1. And the a dx, okay, a is equal to 0. So when I differentiate that, I'll get 0, okay? So I have all the terms I need here. And we say that the differential for this side, okay, let me go and quote it somewhere for you so that I'm just reminding you, okay? So now the differential dx of integral from a to b of some f of xt dt is always equal to f of xb times db dx minus f of xa times dA dx plus integral a to b del x of f of xt, okay, dt. So this is what we have. Now if you remember, we said that our f of xt in the question was given as this, okay? So I'll just want you to go through it and keep it, okay? Keep it somewhere. This is our f of xt, this one. And this is our f of xx, that is the f of xb in effect, okay? So is this one. F of xa is this one. And that one, I think, is cos x times y of 0, all right? And these are the terms that we need. So what I do is just go through it and put it there. So the differential of this from 0 to x, then we have cos of x minus t, y of t dt will then be equal to f of xx, that is f of sb was given as f of xx, and that was what, y of x in the question. That is what we just discussed, or we just found, okay? And then the b dx was given as 1 because the b was x, and so when you differentiate with respect to x, you get 1. And minus f of xa is the same as f of x0, and that is this one, okay? The one that I've covered with the box, okay, in the orange or yellow color, whatever it is. And you go through it, you put it there. But if you remember, dA dx is actually d0 dx. That is the differential of 0 with respect to x, and that gave us 0. So it means everything will tend to 0, then plus integral from 0 to x. Now I have to differentiate this function, this here, whatever that is inside with respect to what, x. And when I do that, I will get differential of course will give me sine, okay, minus sine, okay. And so I'll get something like where is my work? I'll get something like minus sine of x minus t. Actually, I have to also differentiate whatever that is inside the cos, okay, that is the x minus t with respect to x, and I will get 1. So I'll have to get minus sine of x minus t, okay, and y of t dt. That is all. So in effect, we have y of x minus integral from 0 to x sine of x minus t y of t dt. Okay, so I'll have to, this is just the differential for this term, okay? So it means when I go back to my equation, which is this equation, okay, wherever I see this in the differential of the integrals, I have to come and put what we've got in here, this whole thing here, inside there, okay? So I'll have to put this here, that then I'll have what, y of x, you had y of x plus integral from 0 to x, was it plus? No, it was minus actually, okay, integral from 0 to x, and so we had sine of what, x minus t y of t, and that was equal to dt. Actually is here x. Okay, so per what you know, you are supposed to differentiate, keep on differentiating before we get to a point that we won't get any different integral sign in it. Okay, but we still have the integral sign present, so we'll have to continue and differentiate the whole of this equation again. So let's probably call this equation, let's say equation 2, and call the main equation as equation 1. Okay, let's call this as equation 2 and call this main equation, that is a question given, this one as equation 1. Okay, let me erase it because we'll need them back. Okay, let's call this equation 1. Okay, so we've gotten an equation 2 here. So now I have to differentiate equation 2 again, and when you differentiate, I'm just differentiating everything straight. This time I won't go through the differentiation and the integral sign. I'll just quote it there, and I presume I'll just think that you'll be able to go through it by yourself. Okay, so I differentiate y of x and I'll get y prime of x. Okay, or I can say y of y prime, just like that, and minus. Okay, so to differentiate this, we said first of all you have to get your f of xt, and this is it. Okay, then you find your f of xb, and f of xb is just putting wherever you see t in the f of xt, you put x there. So when I put x here, it will be sine of x minus x, and that will give me 0. Okay, so sine of 0 will actually also give me what? 0. Multiply by db dx, and it still give me 0 because I have 0 multiplied by dv dx. So I'll have 0 minus, and I go to the f of xa. Okay, f of xa, this is my a, which is 0. So f of xa will be just putting 0 in place of t. And this one to give me x minus t will turn to 0. Okay, and I have sine x multiplying y of t. So I'll get sine x times y of t, then multiplied by the differential of 0 with respect to x, and that will also give me 0. So it means that in effect, if I go ahead and then multiply it to my everything, I'll get 0 as well. Okay, and plus the integral from 0 to x, the partial derivative of everything here with respect to x. I'm just going through the differentiation and the integral sign straight away, because if you are supposed to go through it again, it will keep long. Okay, so with this, I have only x here, so I have to just differentiate that part with respect to x. And when you differentiate sign, you get cos. Okay, cos of everything inside, and we differentiate everything that is inside with respect to x, and we get 1, because you have only x minus t. When you differentiate this with respect to x, you get 1 minus 0, and this so it means that you get 1. Okay, I hope you understand this. So then y of t dt. Okay, so this whole thing is equal to, then you differentiate this x, because you are differentiating everything in equation 2 with respect to x, and so this one too I'll get 1. Okay, so I'll have to get y prime, or let's say y prime, let me call it y prime, then minus, okay, whatever that is here, because 0 is 0, 0 minus 0 is still 0, so minus integral from 0 to x, then I have cos of x minus t y of t dt is equal to 1. Okay, but now let's go back to our question and look at something. Where can you find this? Okay, then you go back to the question and realize that in equation 1 you have integral of cos of something, cos of x minus t y of t dt from 0 to x equals what? S squared over 2. So we've gotten this same thing in one of our equations. Okay, so let's call that equation let's say this is equation 3. So, but you can see that from equation 1, this whole thing is equal to s squared over 2. If you don't get it, let me go back and show you what I'm talking about. So from this equation, this whole thing here with the red box is equal to s squared over 2. So just substitute that back in the equation 3 we've gotten. Okay, And so we'll write something like, let me write it down here, but I'll still copy it somewhere. Minus s squared over 2, because that is what was given in equation 1. Okay, so like this, very simple like that. So it means that I have my y prime being equal to 1 plus s squared over 2. Okay, so let's go ahead and solve this, because this becomes a simple ODE. So y prime is the same as dy or dx, and it's equal to 1 plus, okay, s squared on 2. Then I have to do method of separation. 1 plus s squared on 2 all multiplied by dx. Okay, now I integrate this side with respect to x, and I have y, and I have y of x equals, integrate 1 with respect to x, and I'll get x, plus I integrate s squared over 2, I'll get s cubed over 6, and plus a constant c. Okay, so now for us to be able to find our dear constant c, just go back to some of the equations, okay, and look at what you have. This time, if I can get y of something equals something as let's say initial condition, then I'll be able to find c. Okay, so all that we need to do is try to find y of the lower limits. Okay, so the lower limit in a whole integration was actually 0. So what you can do here is, let's try to find an equation that has y of x in it. Okay, and that is the only equation 2. In equation 2, I mean this one, okay, we have y of x minus integral from 0 to x. So let's try to put x equals 0 there and see what will happen. Okay, I'm sorry for that. Or let me come back and actually, so y of 0 in equation 2, I'm putting x wherever I see x, I put in 0. So I have y of 0 minus, because in equation 2 that's what we have. Okay, I'll put x here. Sorry, I put 0 in place of x, and I'll get y of 0. And I'll put 0 at the upper limit, I'll get integral from 0 to 0. Okay, integral from 0 to 0, then sine of something, x minus t, y of t dt is equal to, let's see what is here. Here too we have x, but we said x is equal to what? 0. So equals 0. But integral, a definite integral from one point to the same point is actually equal to 0. Okay, so this whole part will be 0. Okay, so I have y of 0 minus 0 equals 0. So it means that y of 0 is equal to 0. That is, we got this from equation 2. Okay, so with this we can implement it here and say, since we've gotten y of x is equal to x plus s cubed over 6 plus c, and you know that y of 0 is equal to 0. We implement it here and know that 0 is equal to y of 0. So it means wherever I see x, I put it 0, 0 plus c, and c will be equal to 0. So in effect, the whole answer is y of x is equal to x plus s cubed over 6. Okay, I hope you understood everything. So this is a solution to the question. Okay, so let's go through the second one, and then probably we'll be done for the video or for this lesson. Okay, so let's start. With the second one, I'll just move fast because I believe you know much about, or you've gotten the idea about integration or differentiation under the integral sign. Okay, so here to solve this, first of all, the first thing you do is, like I said, you differentiate through everything, but you have what? U of x. Let me write it back again, equals 2x. I'll be differentiating them straight away, and like I said, I'll move fast as well. Okay, u of t dt. Now with this, I have to differentiate through with respect to x. So I have u prime equals 2, okay, 4. Then when I differentiate this with respect to x, using the idea of differentiation under the integral sign, I have my f of xt to be this part. Okay, so my f of xx will be just how do you call it, t. Wherever I see x, I put in, wherever I see t, I put in x. Okay, so I'll be x minus x, and that will be what? 0. So it means that part will give us 0 times something, so we'll get 0, okay? Then minus f of x 0. Here we'll get 0 minus x. Yes, indeed, that is okay. But when you differentiate the x, a is 0. So when you differentiate that, you get 0. And when you multiply by everything at that point as well, you get 0. So it means that you still get 0 here, then plus the integral from 0 to x, then partial derivative of the whole of this with respect to x. And that will give me -1. Then times u of t dt, because you differentiate t minus x with respect to x, and here you get 0 minus 1, so in effect you have -1, okay? I'm just going through so that you understand whatever that I'm writing here, okay? So that is it for the first part, okay? And so it means that u prime will be equal to 2 plus 4 times the integral from 0 to x. Let me change the plus because the negative will affect it. There is a -1 in front of this u, so I have -4. That's then u of t dt. Okay, this is where most students get it wrong, because u prime is equal to, we've gotten this -4 integral from 0 to x, then small u prime u of t dt. Okay, so we have this. Now, I can go ahead and integrate this because I have only a function of t and I'm integrating with respect to t, okay? So I'll go ahead and then integrate it, okay? When I go ahead and do that, I have u prime prime equals, sorry, I'm not actually differential. I'm integrating whatever that is under the integral sign. So 2 minus, then 4 into, when I integrate a function of u or a function of t, I'll still get a function of t. So when I integrate small u of t, let's say I'll get the capital U of t. Then moving from 0 to x. So I have u prime being equal to 2 minus 4 into capital U of x minus capital U of 0. Okay, so I have u prime being equal to 2 minus 4 times capital U of x minus or plus 4 times capital U of 0. Now, there's no integral sign here. We could have, stopped here and say we are done, but no. U of 0, you don't know, okay? Of which you can go ahead and find it. But this capital U of x is actually the integrand, okay? Is the answer we had from an integration. Okay, or let me say everything from here, from this side to this side, is an answer that we had from an integration. I mean, the integral of this gave us the whole of this. So it means this answer we have here is not actually the actual answer. It's actually an integration. Okay, we did some integration to get this. So we have to move away from that part of the integral sign to something else. I don't know if you're able to get this, but what I'm trying to say is that the whole of this from here to here is actually the answer we had from doing this integration, okay? I hope that is okay. Now, it means that these whole answers are in the integral form, okay? Because they are the result of an integration. It means, I don't know, our idea here or our task here is to remove every integration from the equation. Okay, so we have to make sure that we remove the integration answer or the answer from an integration from the whole equation. So what we'll have to do here is simply go ahead and again differentiate the whole of this equation again. And when I differentiate, I'll get u prime prime, because when I differentiate 2 with respect to x, I'll get 0. So I have -4. Then when I differentiate capital U of x, if I differentiate capital U of x, or let's say if I differentiate the whole of this equation with respect to x, I'll have to get a small u of x. I don't know if you get my point. Capital U of x is actually the integral of a small u of x. Okay, same thing happens to this small u of t and then capital U of t that we had. Okay, I mean, let me use the red pen to show you. I mean, this one and this one. Okay, we substituted or we represented the integral of the small u of t with capital U of t. So it means that if I'm supposed to differentiate the capital U of t, I'm supposed to get a small u of t back. So Here, let's say I have a capital U of x is the representation of the integral of a small u of x. So if I differentiate capital U of x, I have to get it back. I have to get a small u of x, okay? So that when I integrate a small u of x, I'll have to get a capital U of x. I hope you get this. In a nutshell, when I integrate a function of x, I'll have to get a function of x. But let's say if I integrate a function of x, I just represent it by the capital of it, okay? So the same thing happens to the differentiation. When I differentiate capital U of x, I have to still get a function in terms of x, and this time it should be a small u of x, okay? In other words, the same small u of x, okay? So this equation turns to u prime prime plus 4u of x, okay, equals 0. For let's say there's a small u of x, okay? Now with this idea here, what you can do is use the idea. This we are done with the conversion, but here if you want to solve, then you have to use the idea in solving ODEs with second order, okay? Now to solve this, we'll have to represent this function by what you call an exponential function, okay? So we let our solution, we don't know the solution there, but let our solution be equal to e to the power rx. Then we can actually substitute u of x back in this equation here, but we don't have u prime prime of x, so we have to find it. So u prime of x will be equal to r e to the rx, because I'm just differentiating e to the rx with respect to x. Then u prime prime will give me r squared e to the rx. So that I come and substitute this and this into this whole equation, okay? Let's call it equation alpha, okay? So put it back in the equation alpha, and we'll get r squared e to the rx, okay, plus 4 e to the rx. I'm just putting them back, okay? And so I have r squared plus 4, and I factor e to the rx, okay, equals 0. So if I divide both sides by e to the rx, I'll get r squared plus 4 equals 0. So I have to solve for my r squared equals negative 4, find square root of both sides. I'll have r being equal to plus or minus 2i, okay? You point this on a calculator using or converting your calculator to complex mode, you get this, okay? Or you can solve that using the quadratic equation, and you get a complex value, okay? Since we said our u of x should be equal to some e to the power rx, and you know that r is equal to plus or minus 2i, when you are solving equations like this and you get complex values, what you get is just pick the positive one, okay? U of x equals e to the 2i, then x, because that is our r. I said we should pick the positive one, okay? So what happened here is that once I have this, I just rearrange it and I have 2xi. And then in complex numbers, when you have e to the alpha I, its correspondence expression in terms of cosine and sine is just cos alpha plus I sine alpha, where alpha is everything that is attached to the I, okay? So what will happen here is you say u of x is equal to some constant, let's say, let me write it first, cos 2x plus I sine 2x, okay? So when we want to remove the imaginary part from it, then you have to introduce some constants here, and that will be a cos 2s plus b sine 2x, okay? That is our general solution to the question. And so if you want to find a particular solution, what you have to do is go back to the equation or the equations and find some initial conditions. Since we have a second order ODE, we'll have to get two initial conditions, okay? So we can go ahead and check some equations from equation 1, or let me say, from equation 1, which I say the equation 1 is just the main question given. Okay, let's call this equation 1. Let's substitute x equals 0 and see what will happen here. When we do that, let's do it together. you put 0 here, and we have u equals u of 0, and we put 0 in place of this, I'll get 0 plus 4 times integral from 0 to x is 0 here, so 0 to 0, and that will also give me 0, so I'll have 0. So in effect, it's like u of 0 is still equal to 0, okay? I hope you get this. So u of 0 will give us 0 from equation 1. I just discussed the same thing in equals 0. So u of 0 equals 0 from equation 1, okay? Then let's go to, equation 2 and see. And which one is our equation 2? That is the equation 2. Let me see. Let me call this, which one? Let me call this one equation 2, okay? And find u prime of 0. Now u prime of 0, this u prime is actually u prime of x. So wherever I see x, I put 0. And I'll get something like u prime of 0 is equal to, here there's just 2 here, so I have only 2. Now we'll have to put x equals 0. So x equals 0 here means integral from 0 to x, 0 to 0 again. And that means we'll get 0 because we said the integral from one point to that same point is 0. So it means I'll get u prime of 0 equals 2 from that equation 2. Okay? So u prime of 0 equals 2. Someone will ask why we need 2 initial conditions, because it's a second order ODE. You have to get 2 initial conditions, okay? Equation 2, okay? And this one is from what? Equation 1, okay? So now we have u of x being equal to a times cos 2x plus b times sine of 2x. Actually, the a and b, you can interchange them. The a can go for the sine or whatever way you want to put it, okay? It's just a constant. And so with this here, from equation 1 or from this one, u of 0 equals 0. So it means 0 is equal to, wherever I see x, I put in 0. Cos of 2 times 0, and that will be 0 plus b sine 0 as well. And cos 0 is just 1, okay? So I have 1 here, and here sine 0 is 0. So I have a equals 0 because I'll get a times 1, which will be a equals 0. Because the b times sine 0 is 0, so here we'll go, and I'll get a equals 0. Then from the other one, since we have u prime of 0 equals 2, we have to find u prime from the general solution. So I have to differentiate the general solution, I mean this one. So u prime of x here from the general solution will be equal to, now differentiate cos 2x with respect to x, and I'll have minus 2a sine 2x, okay? So I have to differentiate whatever that is here, which will give me 2 times the differential of cos, which is minus sine 2x, then plus 2b cos 2x, okay? But we know that u prime of 0 is equal to 2. So it means 2 is equal to, wherever I see x, I put in that 0, and I have minus 2a times sine 2 times a sine, and here is sine 2 times 0, and u is sine 0, so sine 2a times 0, sine 0 is 0, okay? So plus 2b into cos 0, which will be 1, okay? So it means I have 2b being equal to 2, and this would definitely implies that b is equal to 1 and a is 0. So it means, let me write our equations here, or our final solution here. We've gotten a to be 0 and we've gotten b to be equal to 1, okay? So it means that a is what? 0, b is equal to 1. So this is simple. Our particular solution is equal to a is 0, so this part will go, and then b is 1, so I have sine of 2x. Okay? I have sine of 2x to be my solution. Alright, I hope you understood the process. Thank you, and don't forget to subscribe to my channel. In our next discussion, we'll do the other way around. We convert IVPs to VIEs actually. Okay, so stay tuned, and like I said, please just don't forget to subscribe to my channel, share it, like it, and share your comments as well. Okay, see you next time.